Hello everyone, welcome. So we're going to start a new series where we're going to solve last 10 years, right? So previous year solutions last 10 years, right? So first we're going to start with linear algebra. So we will solve last 10 years, right? So first we'll start with 2021 paper, right? So we'll start first problem. So first problem is show that the set S, so they are given the set S which is x comma 2y comma x, where these x comma y are real number. So we need to show that this set is a subspace of R3 of R, right? So here our V is R3 and our field F is R, right? So V of F is a vector space. So our V is R3 and our field is real number. So we need to show this set is a subspace of R3 of R, and also we need to find two bases for this set S, and also we need to find the dimension of this set S, right? Very easy problem. So first of all, we will show that it is a subspace of R3 of R. So what is basis? So a linearly independent set which spans the whole space is a basis, right? And what is the dimension? Number of elements in the basis is the dimension of the set S, right? So first we will show that this set is a subspace of R3 of R. So how we will show that a subset is a subspace? So we know the necessary and sufficient condition for a subset to be a subspace, right? So we already proved the theorem. So if you have seen my videos of linear algebra, you would have answered this very easily, right? So what we have is, so I have already explained that if V is a vector space, right? So if V is a vector space, W, right? So this W is a subspace of V, right? This W will be a subspace of V whenever this W is a subspace, right? So this W is a subspace of V if this happens. What happens? If alpha times W1 plus beta times W2 has to be in W, right? So for every W1 comma W2 belongs to W, and these alpha beta belongs to the field F, right? So you take two elements W1 and W2 in the set capital W, right? You take two elements in W and you take alpha beta from the field, right? So we have our V and we have our F, right? So this F is a field. You take two elements in the field. So you take W1, W2 from the set W. You take two elements from the field F, and if this combination alpha times W1 plus beta times W2, if this element is also in W, then we say this W is a subspace. This is the necessary and sufficient condition for a subset to be a subspace, right? So we have a vector space V, we have a subset W of V. This subset will be a subspace if alpha times W1 plus beta times W2 is in W, where this W1, W2 belongs to the subspace, the subset W, and alpha beta belongs to the field F, right? So we need to show this alpha times W1 plus beta times W2 is in W, right? Okay. So here what is our field? Our field is R, and our V is R3, right? Okay. So we will start solution. So what we need to do is we need to show that this linear combination alpha times W1 plus beta times W2 is also in W, right? So here our W is S. They have given W to be equal to S here, right? Okay. So what is the set S? So set S they are given to be x comma 2y comma x, and these xy are real numbers, right? And these xy are real number. So what we need to show is we need to show alpha times W1 plus beta times W2 is also in W. So let us take alpha beta belongs to, we need to choose alpha beta from F. Our F is R. So I'm taking two element alpha beta from the field R. Now we need to choose W1, W2. We need to choose two element from W. Here our W is S. So let us take W1. So let us take two elements W1 and W2. So what is W1? So you need to choose one element, right? So let us take the element to be equal to x1 comma 2y1 comma x1, right? x1 comma 2y1 comma x1. So I'm taking another element. Let us call that as x2 comma 2y2 comma x2, right? So I have taken W1, W2 from W, and I have taken alpha, beta from the field, which is here R, right? So we need to show alpha times W1 plus beta times W2 is also in W, right? So here W is S. So what is alpha times W1 plus beta times W2? So this will be alpha times. So W1 is X1, comma 2Y1, comma X1, right? Plus beta times, what is W2? So W2 by our assumption is X2, comma 2Y2, comma X2, right? So remember, these X1, Y1, these X1 and Y1 are real number, and again these X2 and Y2 are real number, right? Because these XY are real number, right? Okay. So we need to show alpha times W1 plus beta times W2 is also in W. So here W is S, right? So we need to show that this element is also in S, right? Okay. So this I can write this as alpha times X1. So I'm just multiplying alpha inside. So alpha times 2Y1, alpha times X1, plus if I multiply beta inside, we will have beta times X2, beta times 2 times Y2, beta times X2, right? Beta times X2. Now what I can do is, I'm just going to add these two tuples. So if I add this, we'll be having alpha times X1 plus beta times X2, right? And if I add these two, if I take 2 outside, right, I can take 2 outside. So alpha times Y1 plus beta times Y2. So this will be our second element, right? So this is a first, this is second, and what will be the third? Alpha times X1 plus beta times X2, right? I'm just adding these two tuples, that's it, right? Okay. Now you can see what is X1, X2, X1, X2, Y1, Y2, all are real number, and this alpha, beta is also a real number, right? So overall, this sum is going to be a real number, right? Why? Alpha is real number, X1 is real number, beta is real number, X2 is real number. So product of two real number is real number, product of two real number is real number, sum of two real number is real number. So this will be a real number, right? This will be a real number, and 2 times this will be again a real number. Why? Alpha is a real number, beta is a real number, because alpha, beta are from the field, our field is real number, and Y1, Y2 again it is in R, right? Both are real number. So that means this combination is a real number, this combination is a real number, again this combination is also a real number, right? So what I can do is, I'm going to assume this to be some P, right? Let us assume that to be P, right? So P is alpha times X1 plus beta times X2. This P is a real number. And let us say this is Q, right? So I'm assuming Q to be equal to alpha Y1 plus beta Y2. And let us say that is equal to R, right? Where this P, Q, R, P, Q, R are real number, right? R, I can use this to be P again, right? Because both are same element, right? Alpha X1 plus beta X2, alpha X1 plus beta X2. So let us call this to be equal to P again, where this PQ are real number. Why PQ are real number? Because P is alpha times X1 plus beta times X2. Alpha, beta real number, X1, X2 real number, sum of real numbers again real number, product of real numbers again real number. So this PQ belongs to this real number. So therefore, this is of the form P, 2X, 2Y, X, right? So this element will be in this set S, obviously, right? Why? Real number, 2 times real number, again that real number, right? So both are of same pattern, right? X, 2Y, X. So you can see P, 2Q. So this PQ are real number. So obviously this belongs to the set S, right? This belongs to the set S. So this belongs to the set S. So therefore, I have taken W1 and W2. So I have taken 2 element. Okay, let us take this 2 element to be in the set S, right? Both are, that is W1 and W2. So I am taking 2 element W1, W2 from the subset. Here subset is S. So let us call this, okay, let us write it here, right? So this W1 I have taken W1 and W2 belongs to S, and I have said alpha times W1 plus beta times W2 is also is in S. So therefore, the set S is a subspace. The set S is a subspace, right? So in order to show that the set is a subspace, you need to work like this, right? We have given many examples. If you have seen my lectures on linear algebra, this you can do this in 1 or 2 minutes, right? So you just have to take two elements W1, W2 from the subset. You take alpha, beta from the field. You just show that this element alpha times W1 plus beta times W2 is also in the set S. So therefore, this subset now becomes subspace because of satisfying the condition alpha W1 plus beta times W2 is also in the set S, right? So we are done with the first part. Now we need to show, okay, now we need to find two bases for S, right? So what is basis? A linearly independent set which spans the whole space. That will be a basis, right? So what we will do is, now we will find basis, right? Now we will find basis. So what is the set S? Now this set is a subspace now, right? Why it is a subspace? Because satisfies the condition, necessary and sufficient condition, right? So what is the set S here? The set S here is x comma 2y comma x, and these xy are real number, and this xy are real number, right? So here I have assumed this alpha times x1 plus beta times x2 to be some p, right? If you want to just say where p is equal to alpha times x1 plus beta times x2, where q is equal to alpha y1 plus beta y2, right? Okay. Now we need to find the basis, right? We need to find the basis for this subspace. So what I can do is I can write this as x times, so 1 comma 0 comma 1 plus y times 0 comma 2 comma 0, right? So both are same, right? So if I take x outside, so 1 1 0 because there is no x term here, and if I take y outside, here there is no y, there is no y, here we have 2. So if you add these two, you will get this term, right? X plus 0, 0 plus 2y, x plus 0. That means the set S is spanned by these two elements, right? The set S is spanned by, so I can span the entire set with the help of these two elements, right? With the help of these two elements. So if you haven't watched my linear algebra videos, go through that, right? Because I am saying a word like span, I am saying a word like subspace, I am saying a word like basis. So you will understand all only if you understand all the concepts. So I'll give that in the description. I'll give you all my videos. You just go through that, right? Okay. So the set S is spanned by these two elements, right? Spanned by these two elements 1 0 1 and 0 2 0. That is, with these two elements, I can able to bring all the elements of S. That is, with these two elements, if I make a linear combination of these two elements, I can bring all the set S, right? Even though this set is an infinite set, right? Why? Because this xy are real number, there are many elements in the set S, but all these elements, I can bring all the elements with the help of these two elements alone, right? Why? How? I can just linear combine these two elements, alpha times 1 0 1 plus beta times 0 2 0. If I vary alpha beta, I can get the entire set S. How? Because so alpha times 1 0 1 plus beta times 0 2 0, right? So if I vary alpha beta, I can span the entire set. I can bring all the elements of set S with the help of this alpha beta, right? If I vary alpha beta. So this set is spanned by these two elements 1 0 1 and 0 2 0, right? Now if I say that these two are linearly independent, then this set will be a basis. Why? A linearly independent set which spans the whole space is a basis. Now we have said that this set S is spanned by these two vectors or elements. Now if I say this is a linearly independent set, if I say these two are linearly independent, I can say that this is a basis, right? This is a basis. That is, this set is a basis, right? Okay. So we will show that these two are linearly independent now, right? So obviously these two are linearly independent, right? Because you cannot write one vector as a linear combination of other, right? So obviously you can see you cannot. Now we will show. Okay, now we will show that these two are linearly independent now, right? So if I say that these two are linearly independent means now this will be the basis for the set S, right? Now we'll show this these two are linearly independent now. Now we'll show that these two are linearly independent, right? So very simple. So by observation itself, you can say these two are linearly independent, right? Because you cannot write this element as a linear combination of this element, and you cannot able to write this element as a linear combination of this element, right? Very simple. So if you want to go by definition, so these two will be linearly independent. Then what is the definition of linear independence and dependence? So we will show that this is a linearly independent set. So that means x1 times 1 0 1 plus x2 times 0 2 0 is equal to 0 comma 0 comma 0, right? So if you can find at least one non-zero x1 x2, then this will be linearly dependent. If x1 x2 both are 0, then it is linearly independent, right? Very simple. This is the definition of linearly independent and dependent, right? So if you can able to find a non-zero x1 x2, a non-zero x1 or x2, then this will be linearly dependent. If both x1 and x2 are 0, that is this linear combination will be equal to 0 only when this x1 x2 are 0, then it will be linearly independent, right? So obviously this will be equal to 0 only when x1 x2 are 0. So you cannot find x1 and x2 such that you cannot find two number such that you can think of it, right? You can think of any number, you cannot find x1 and x2 such that if you plug x1 and x2 here, if you add it up, it has to give you a 0 vector. The only possible x1 x2 is both has to be equal to 0, right? Or else you can form a system of equations and you can able to solve also. So but naturally this implies this x1 and x2 both has to be equal to 0, then only this will be equal to 0. You cannot find a non-zero x1 x2 such that this happens, right? Okay, that means what? That means what? So both are 0, that means the set is linearly independent, right? So therefore the set S, so this set is a linearly independent set, and also it spans the subspace S. So therefore the basis, right? So therefore the basis is, this will be a basis. This spans the space, and since it is linearly independent, we can also say it is a basis also, right? So therefore the basis for the set S is what is the basis? 1 0 1 1 0 1 and 0 2 0, right? So this is the basis for S. That is, with the help of these two elements, I can span the entire vector space, and also this forms a basis, right? Okay. So what is the dimension? Dimension is nothing but number of elements in the basis, right? So there are two elements, right? So 1 and 2. So you need to choose this as one element, right? Because our vector space is R3, right? So this is a one element, this is one element. So what is the dimension? So what is dimension? So dimension is number of elements in the basis, right? Number of elements in the we can talk about dimension only if the basis is finite, right? So if only we can talk about dimension only for a finite dimensional vector space, right? So R3 of R is a finite dimensional vector space. Dimension is 3, right? So it is a finite dimensional vector space. So if it is a finite dimensional vector space, we can talk about the dimension. What is dimension? Dimension is the number of elements in the basis. So how many elements in the basis? There are two elements in the basis. So therefore dimension. So what is dimension? If you go by definition, so dimension is, we can talk about dimension only for a finite dimensional vector space. So here our vector space is finite dimensional, R3 of R, which is of dimension 3, right? So dimension is number of elements. So number of elements in the basis, number of elements in the basis. So therefore there are two elements. So therefore dimension is 2, basis is 1 0 1 0 2 0, right? So they have asked two bases, right? So we have shown that this is a subspace of R3 of R, and we have also found that the dimension of the set is 2, Now they also asked us to find the two bases of S, right? If you find one basis, you can find infinite number of bases. How? You just make a linear combination, then you can find many number of bases. So one of the bases is 1 0 1 0 2 0. So you just make a linear combination, alpha times beta times alpha times 1 0 1 plus beta times 0 2 0. If you vary alpha beta real number. So whatever alpha beta you put, that two will be always linearly independent, right? So you can find infinite number of bases if you find one basis itself. So the two bases are, so I write it here, two bases. So they have asked us to find two bases. So two bases are, so I'm putting BASCS because we are finding more than one, right? Here I have used SIS, right? I used SIS. Okay. So the first basis is, so you can write that this itself, because this is also one of the bases, right? If I put x1 to be equal, if I put x and y to be equal to 1, then you will have 1 0 1 0 2 0. Okay. So 1 0 1 0 2 0, right? This is one basis. 1 0 1 and 0 2 0. This is one basis, right? And also any linear combination will also be basis. So for example, if you put x to be equal to, if you put x to be equal to 2, right? If you put x to be equal to 2, let us put x to be equal to 2, y to be equal to 2 again, right? Y to be equal to 2 again. So you just, if I put x to be equal to 2, if we multiply 2 here, so we have 2 0 2. If we multiply 2 here, we have 0 4 0, right? So again, this will also a linearly independent set. This will also span the entire vectors, entire subspace, right? So you just make some so you just multiply with suitable alpha, suitable scalar, right? That will all form a basis, right? You can find infinite number of bases. One of the other bases is you just multiply 2 here, multiply 2 here. So if you want, you can multiply 2 here, multiply 3 here, whatever you want, that will be a basis, right? So we are done with the problem. So in the next class, what we will do is we will move on to the next problem that is asked in 2021 paper, right? So very easy problem. So in order to prove it's a subspace, you need to prove this condition. They have asked us to find two bases, and also we need to find the dimension of the set S, right? So here W is a subspace. Here instead of W, they are given the set S, right? So you take two element W1, W2 in S. You show that alpha times W1 plus beta times W2 is also is in S. Then it will be a subspace. Then dimension and basis are very easy, right? So the next class we will move on to the next problem, right? So thank you. All the best.